All right, get ready to dive into some really fascinating research. I mean, really fascinating stuff.
Oh, absolutely.
We're talking about Barrett's esophagus.
Yeah.
And it's linked to esophageal adenocarcinoma, which is a type of cancer, a very serious type of cancer.
Yes.
You definitely want to catch this early.
For sure.
And what makes this deep dive even more exciting is that we're actually looking at findings that haven't even been published yet.
That's right, hot off the presses.
Like you are getting a sneak peek.
A world exclusive.
This is big stuff, folks.
Yeah, definitely. We're talking about a protein called p53. It's a pretty big deal in the world of cancer prevention.
It's kind of got a cool nickname.
Oh, yeah.
The guardian of the genome. Like, how cool is that?
That's a pretty awesome name. It's very fitting. It really does act like a security guard for our cells, constantly on the lookout for any damage to our DNA.
So it's like if there's damage, it's like the repair crews comes in and fixes it.
Exactly. If p53 finds a problem, it can actually hit the pause button on the cell's growth to give it time to repair. Or if the damage is too severe, it can trigger the cell to kind of self-destruct, and that prevents it from becoming cancerous.
So this is where things get really interesting. We're going to talk about this technique called immunohistochemistry.
IHC for short.
IHC for short. And it's like this tool pathologists use to examine tissues under a microscope.
Yeah, it's like a detective tool. It uses special antibodies that bind to certain proteins, and these antibodies are linked to a dye so that they light up under a microscope. So it allows the pathologist to see things that you wouldn't be able to see otherwise.
It's like highlighting the bad guys.
Yeah, exactly.
Now, to really grasp the importance of this research, we need to understand what happens when our guardian of the genome, our p53, isn't functioning as it should. And that's where things take a bit of a turn.
Yeah.
Now, everybody has p53 working hard in their cells, but the gene that makes p53, called TP53, can mutate.
And that is a big deal because TP53 is actually the most frequently mutated gene in human cancers.
So this is like a superhero gone rogue.
Yeah, kind of. When TP53 mutates, it disables p53's superpowers. These mutations can prevent p53 from halting the cell cycle for repairs or initiating that self-destruct sequence that we were just talking about. And that means that damaged cells can multiply uncontrollably, and that increases the risk of cancer.
So it's like you have this Border Patrol agent, and he's supposed to be checking those papers and make sure everything's okay. But then the instructions get all scrambled, and he's just waving everybody through, no questions asked.
Yeah, good analogy. Very good analogy. And what makes this research so interesting is that it's specifically looking at the role of these TP53 mutations in Barrett's esophagus.
Right.
And remember, we're talking about unpublished data here. This is cutting-edge stuff.
So we've got this condition, Barrett's esophagus, which we know is linked to a higher risk of esophageal cancer.
Yeah.
And we've got these TP53 mutations, which can throw a wrench into the body's natural defense system. So what did the researchers find when they started looking into this?
They examined tissue samples from people with Barrett's esophagus and esophageal adenocarcinoma.
Right.
And using IHC, they were able to see whether p53 was functioning normally or showing sign of these mutations.
So they were looking for evidence of p53 gone bad.
Exactly. And what they found was a very strong correlation between abnormal p53 staining patterns and the presence of TP53 mutations.
Hold on, you said abnormal p53 staining patterns.
Yes.
What are those exactly, and what do they tell us?
Sure. So when pathologists are looking at p53 using IHC, they're looking for these specific patterns that can signal trouble.
Okay.
One pattern is overexpression.
Overexpression, okay.
Where there's just too much p53 present. And this often indicates a missense mutation.
Missense.
Meaning the TP53 gene is producing a wonky version of p53.
So it's like the cell's making a ton of p53, but it's like the wrong kind of p53.
Exactly. Yeah, it's not actually doing its job properly. Then there's the null pattern,
okay,
where there's no detectable p53 at all. And this is usually due to more serious mutations like deletions or frame shifts, which basically prevent the production of any functional p53.
So overexpression is like having a security guard who's like super enthusiastic but clueless?
Yes.
And the null pattern is like having no security guard at all.
Exactly.
Neither is good.
No.
And I remember from the research, there are also some rarer patterns. Like, what about those?
You're right. One example is cytoplasmic staining.
Cytoplasmic staining, okay.
Where the p53 is found in the wrong part of the cell.
So it's like the security guards wandered off to the break room instead of like, patrolling the perimeter.
Yeah, that's a good way to think about it.
So these abnormal p53 patterns, particularly the overexpression and the null pattern, are red flags that something might be up with TP53.
Yes.
And remember, we're talking about TP53 mutations being strongly linked to the development of esophageal adenocarcinoma in people with Barrett's esophagus. And this is where this research gets super exciting.
Yeah.
They're proposing these very specific, easy-to-use criteria for pathologists to interpret these p53 patterns.
This is a huge step towards standardizing p53 analysis.
Okay.
You see, in the past, sometimes inconsistencies in antibodies, staining techniques, and even interpretation methods meant that different labs would get different results for the same sample.
Oh, wow.
Not ideal when you're dealing with cancer. So this research is trying to create a more unified and reliable approach to using p53 IHC.
And this is what makes this, like sharing this with our listeners before publication, so cool. You're getting a front row seat to some potentially game-changing research.
Absolutely.
It's important to remember that p53 IHC is just one piece of the puzzle when diagnosing and managing Barrett's esophagus.
Of course, yeah.
Researchers are also looking at other promising biomarkers, things like AGRN, a protein that's involved in maintaining the integrity of that esophageal lining.
Right.
And there's TissueCypher, which is a test that analyzes multiple protein biomarkers, including p53, to actually assess a patient's risk of developing esophageal adenocarcinoma.
Yeah, that's a fascinating one.
Sounds like the researchers are really pulling out all the stops to develop better tools for tackling this disease.
Absolutely. It's a very active area of research.
So with all this talk about p53 and cutting-edge research, let's bring it back to our listener. Why should they care about this? What makes this deep dive relevant to them?
Well, first of all, p53 is crucial for preventing cancer in everyone, not just those with Barrett's esophagus.
Right.
Understanding how it works and what can go wrong helps us all appreciate the complexities of cancer development and the importance of early detection.
It's like learning about the intricate security system that keeps our bodies running smoothly.
Exactly.
But what about this specific research? What makes it so impactful?
This research represents a major step towards personalized medicine.
Personalized medicine, okay.
By pinpointing specific biomarkers like p53 mutations, doctors can tailor treatment plans to individual patients. And that increases the chances of success and minimizes unnecessary interventions.
So it's all about getting the right treatment to the right patient at the right time.
Precisely.
And beyond Barrett's esophagus, this research has implications for a wide range of cancers. I mean, if we can refine and standardize p53 IHC for one type of cancer, why not others? The possibilities are really quite exciting.
Absolutely. This is just the tip of the iceberg.
It's like this research is a launching pad for new discoveries and advancements in cancer treatment. So stay tuned, folks, because we're about to dive even deeper into the specifics of this groundbreaking research. We'll uncover even more fascinating insights after a quick break.
Sounds good.
And we are back. So we've been talking all about this p53 IHC and how it can help pathologists really get a good look at what's happening at the cellular level and spot those early warning signs for Barrett's esophagus. But I want to get into what makes this specific research we're talking about so special. What's new here?
So this research really gets into the nitty-gritty of p53 staining patterns.
Okay.
It's not just a simple yes or no, normal or abnormal situation.
Right.
The researchers have really mapped out all the different ways p53 can show up under a microscope.
Okay.
And what those patterns might mean. One of the probably the most interesting findings is this thing they call the one gland rule.
Oh, yeah, the one gland rule. I remember reading about that. What is the one gland rule?
So they found that if even a single gland, just one,
Wow.
in the tissue sample shows strong p53 staining, it's a strong indicator of dysplasia.
So one tiny gland could be a huge red flag.
Absolutely, yeah. It really highlights how sensitive this technique is. And the beauty of the one gland rule is its simplicity. It doesn't require complex calculations or subjective interpretations. It's a really clear-cut sign.
It's like a smoke detector going off. You know, you don't know exactly where the fire is, but you know you need to do something right away.
Exactly.
Wow. So this research seems like it could be a real game changer for early detection.
Absolutely. And, this is what makes this unpublished data so exciting. We're talking about potentially being able to identify people who are at risk of developing esophageal cancer even before there are any visible signs or symptoms.
That's incredible. But we also talked about how different labs sometimes get different results when they're doing p53 IHC. Does this research address that problem at all?
It does. Remember those inconsistencies we talked about?
Right.
Different antibodies, different staining protocols, different interpretation methods, all of those things can lead to variability in results.
Right.
This research is a big step towards standardizing p53 analysis. So the goal is to make sure that no matter where a tissue sample is analyzed,
Right.
the results are reliable and consistent.
So it's like creating this universal language for p53.
Exactly.
That's incredible. So this standardization could be really huge for patients. It means greater confidence in diagnoses, more targeted treatment plans, and potentially much better outcomes.
Yeah, for sure.
Now, before we wrap up, I want to circle back to some of those other promising biomarkers and technologies we talked about earlier. I'm especially interested in AGRN.
Right.
What's the latest on that front?
So AGRN is showing a lot of promise, and as we discussed, it's a protein found in that basement membrane, the supportive layer beneath the esophageal lining.
Right, right.
And what's interesting is that researchers are finding that loss of AGRM expression is very strongly linked to the development of dysplasia and esophageal adenocarcinoma.
So it's like another piece of the puzzle, another clue for pathologists to look for.
Exactly. And because AGRM loss seems to happen early in the process,
Okay.
it could be really valuable for what we call risk stratification.
Risk stratification.
Yeah, so doctors can use it to identify patients who might need closer monitoring or more aggressive treatment.
And how about TissueCypher? Where does that fit in?
So TissueCypher is really interesting because it kind of takes a multi-pronged approach.
Okay.
It analyzes multiple protein biomarkers,
Right.
including p53, including AGRN, to really thoroughly assess the patient's risk of progressing to esophageal adenocarcinoma.
So it's like having a whole team of experts
Yes.
weighing in rather than relying on just one opinion.
Exactly. That's a great analogy. And it really acknowledges the complexity of cancer development, right? It's not a simple process. By looking at these multiple biomarkers, TissueCypher can provide a much more comprehensive and nuanced picture of a patient's risk.
And of course, we can't forget about AI. Where do things stand with AI and Barrett's esophagus diagnosis?
Yeah, AI is still in its early stages
Right.
in this field, but the potential is huge. Imagine algorithms that can analyze these images of tissue samples with incredible speed and accuracy, potentially spotting things that even the most experienced pathologist might miss.
It seems like the world of Barrett's esophagus diagnosis is really on the verge of this technological revolution.
Absolutely.
Wow, this has been a really fascinating deep dive. I feel like I've learned so much, and I'm sure our listeners have too. So as we're wrapping things up, what's that one key message you want to leave our listeners with?
I think the most important thing to remember is that this field of research is so dynamic and there's so much hope. We're really seeing these incredible advancements in our understanding of this condition, and new tools for diagnosis and treatment are emerging all the time.
So there's a lot to be optimistic about.
Absolutely. And this research on p53 IHC is a perfect example. It's groundbreaking work, and it has the potential to really change the way we approach Barrett's esophagus, leading to earlier detection, more personalized care, and ultimately better outcomes for patients.
Well, that's a great note to end on. And remember, this is just a sneak peek at some unpublished research. Stay tuned for the official publication in the coming months. You'll be among the first to know when it drops. Until then, keep those brains buzzing and never stop diving deep into the world of knowledge.